Minutes. There we go. A few people are still coming in, so I was going to give it a couple minutes, but I'll take the opportunity to explain a little bit of what this talk is all about. First off, I appreciate the opportunity to be able to present on this information that we've sort of been bouncing around in the US a bit to a more international audience. Really, a lot of this has come out of the social engineering stuff that's been discussed lately. A lot of where it's been applied is trying to break into different areas and tricking people into giving up information. But these tools are applicable to a number of areas that can be used toward certain goals that I think are universal to the hacker community. It's necessary to define those goals, to say how these tools are useful. And the easiest way we came up with to identify those goals is hacking is creating interesting solutions to difficult problems, whether those be technical problems, whether those be social problems. People are faced every day with problems that require a large number of different skills to face. And one of the places where we see advances in any field is when someone crosses between two disciplines. A solution that requires tools that are available within another specialty. You see this happen within organizations, within companies. So trying to find ways of solving that in a quick way. But first off, how to herd cats, where that came from. I found out from talking to some people that it's not a very clear title. It specifically refers to getting creative people, meaning people with skills in different areas, to work together. It's commonly a problem that more managers face. The best people at this, unfortunately, are often drawn into communities such as open source development or are bought up by companies as technical managers, which everyone knows a good technical manager is a very valuable resource for some of these companies. But people, small groups, are still facing problems that require this kind of organization. And so what we've been talking about lately is coming up with these basic descriptions of these tools that strip off the manager talk, that strip off the market speak, and things like that, and apply very simple ways that a group can organize toward accomplishing a common goal. The reason this isn't done more heavily and hasn't been done in the past is people don't often have a unified will, a reason to head toward a specific goal. People don't do something because they can. People don't do something because they should. People do things because they want to, and they do only what they want to. So ways that people can agree even on what to do and what's worthwhile and to share resources toward that goal is something that doesn't happen much, especially within the enthusiast groups. People come together for no clear reason, and often it's because they have a similar interest, and those interests will cover a wide range. For instance, as many of you know, in an IT department, you have multiple subcategories. You might have a security guy, you might have multiple security guys. Maybe one of them's involved in crypto, maybe one of them's involved in physical security, maybe one of them's involved in your actual authentication versus the crypto guy. So they're in the same area, but they're completely different specialties. You might have a DBA guy who's working with your crypto guy to make sure that your database is secure. But each of them is having to pull on the expertise of the other to accomplish their goals. So you see a lot of this crossover. First off, a little cultural information. This talk was sort of written toward helping 2600 self-organize a little bit. 2600 is a hackers group in America. It's national, it's actually international, and the problem is that there isn't a whole lot of organization. By its nature, it's a public group where the CCC meets in private areas funded by the dues of the members in regional groups. The 2600 group, there are no dues. You pay nothing. Nobody's a member of 2600 really. People just sort of show up at agreed upon public places. The service that the national group really provides is the IRC network, the magazine, which is where most of the funds come from, and the website, which provides information about where these meetings are. So it's like a tracker site more than any kind of organization for the groups. So what happens is you have people show up at these meetings who have a general interest in hacking. They don't know what it is. You know, they come in and they're like, oh, I want to break into computers. But their specialty might be, you know, something completely obscure but interesting. You get a doctor who comes in. He's like, I want to break into computers. Well, realistically, we're not going to show you how to break into computers. There are a number of programs you can download if you want to be a script kiddie. But we're not going to be able to teach you about memory management. We're not going to be able to teach you about all these different things to get you to the point where you can do honest research quickly. There just isn't a way. People have tried to figure out ways at the meetings we go to, but you'd have to teach the basics every week because new people come in. How do you face the problem of getting those new people up to speed? And it's not so much a problem, I understand, with the CCC, because the CCC's regional groups sponsor projects and they buy the resources for those projects. And the difference is, if you have a group of people and say they want to learn microcontroller programming, all right? But they don't have any microcontrollers, and they don't have any programmer boards, and they don't have all these basic resources. That means that not only do they have to want to, which isn't necessarily difficult, you can get people excited about a lot of different things, but they also now have to buy resources towards accomplishing that goal. And that's based on the idea that you have different types of learning. You have transmission learning, which is where one person speaks and everybody else sort of absorbs what he says, right? And then you have collective learning, like a workshop, where you're actually using your hands, you're doing. If people apply a chain of tools toward accomplishing a goal in the future, when they're faced with a problem that is made up of that goal at some point, then they'll immediately remember, oh, that tool works for that goal, for that problem, so I can apply that tool. Even if it's only a small part of the problem, then it's still a part of the solution. And one of the things you see with these groups that are put together, for instance, the CTF team has a very diverse goal. For those of you who don't know what CTF is, it's Capture the Flag. It's played at DEF CON, and it's also sponsored by some universities. Brooklyn Polytechnic really recently had a game. There's new games coming out that are based around virtual machines, and you have access to a machine on this virtual network, and services are being run on another machine and you hack into it. At the same time, you have to protect your own machine. Sometimes this is done by you bring in your own equipment, run your own software, and people try to hack you. But to lock down your team's equipment takes a large amount of skill. To code exploits for the other people's servers takes another set of skills, related but separate. A specialty. People can spend their entire careers centering on, penetration testing, and people can spend their entire careers specializing on actual exploitation. They seem like the same thing, but they're not. For instance, a friend of mine was just talking about automated penetration testing, where you take large databases of vulnerabilities, and as you can see, the more tools become available, the more each of these things will specialize. But it's still beneficial when faced with some of the problems that the community is interested in, to be able to have access to the skills and concepts that are available to specialties within not only technical fields, but also liberal arts, for instance. Philosophy has a number of tools that they've created, like logic tables, things like that, which are touched upon in other fields. You'll get actually a little bit of philosophy in your binary mathematics classes for your computer science degree, because it's an applicable tool, but they don't mention all of the other little things that have been done to make it more powerful, side tools. So you end up with this idea that, yes, I can do this with this field, but then you require an expert in that field to actually tell you, all right, this is how it's done. So where do these skills come together? And that's sort of what the idea was. So let's talk about some of the places where this happens. You have enthusiast groups, LUGs, also Linux users groups, which are a little bit more specific than the hacker groups. You have bugs, BSD users groups. You have Unigroup, which is a group that has analogies in other groups that's based in New York that is supposed to be an overarching computer group. They're interested in programming, they're interested in hardware. They have speakers come in on multiple different topics, sometimes very loosely related, but always somewhere near computing. And you have hackerspaces, which is a new thing we're seeing happening, at least in the States. I understand the CCC has had the private spaces for a while, but that's where a group buys into a space collectively to work on different projects. Never really to work as a group toward one project unless there's some really, really excellent reason. For instance, the CTF games is one of the most common things that you see a lot of people work on together, simply because it requires that. It's one of the only goals that are presented to the community as being worthwhile that requires, right off the bat, organization, not only to create the game, a worthwhile game. You know, you can't just put up a copy of Apache and say, oh yeah, that version's, you know, exploitable, go to it. You have to, if you really want to make it worthwhile, create your own custom exploitable code and then provide them a copy of the source code so that they have to do it themselves. That takes time, that takes energy. Setting up the game so there's not cheap little things that you can do. I mean, sometimes that's worthwhile, but for instance, if there's a simple local root exploit that you weren't even aware of, and it's been on the net for months, and somebody just uses it, doesn't even play any of the levels, beats everybody, that's not very fun. People have spent possibly days working on getting to level 3, and this one person went from level 2 to root. So it's important because you learn what people are doing, but it's not terribly good because it goes against the spirit of the game. So let's talk about doing. When you're actually doing a project, you end up having to put together this team of different skills. And if you don't know the goal that are necessary to accomplish this meta goal, let's say you want to cure cancer. Well, you can't just tell a computer, cure cancer, you know. You have to write the software, you have to create the hypothesis, and you have to test them. The scientific method is surprisingly little known outside of those fields where it's directly applicable. And yet, any time you're faced with a problem, there are ways of solving it quickly and efficiently. What you do is you first have to specify, here is my problem. These are the different ways I can solve the last step. Sometimes people face that. Sometimes people say, well, these are the steps I think I have to take. But even choosing which steps they think they have to take is making decisions based on their previous experience. Trying to bring in new skills to face these problems requires a team effort. But usually it's not the team that creates the new idea for facing a problem. It's somebody who understands both sides directly of a problem and then applies a solution and asks the experts. And then they go, oh, wow, you know, that's an incredible idea. Why didn't I think of that? Well, because you had a way that you already preferred to do this little step, so you used it. It's difficult to synopsize complex technical information, which is what a lot of these talks try to do. If you walk into a talk on RSA, like Shardy gave, you'll be sort of lost unless you understand the basics of cryptography. And yet, a number of people who come to these conferences, who come to the meetings, want to learn the basics. They want to learn the concepts, but there's really no opportunity to do that. It's RTFM, you know, read the fucking manual. You need to learn on your own. And that's part of the mindset of the community. But a lot of people are trying to break that because it's beneficial. You never know, you know, who's going to be the next Einstein. The more people you can have think about complex problems that would normally require years of education, you know. Maybe somebody is a relational genius, and the only way it's ever going to be found is if they work on a complex project that requires them to really think about these problems, and they have access to experts to tell them, all right, this is possible, this is possible, this is possible, and then they say, oh my God, this is possible, you know? So it's difficult to get people into positions where their potential becomes clear. The textfiles.com guy, I think, said it best when he said, we should focus the power of all the hackers like a laser, which is actually made fun of a lot because it's sort of silly. Everybody knows that the idea is to work toward what you think only you are capable of making good decisions about what you should be doing. It's a big idea. The lone wolf, the single person working on a project, and part of that I think comes from ego. A lot of the people you see doing really, really cool things are doing really, really cool things instead of really, really important things, because that's where the motivation is. There's a lot of people who enter the scene looking for quick celebrity, looking for recognition of their skills. And sometimes maybe the best way to provide that is to offer them the opportunity, the resources to accomplish their goals. One thing that was actually researched heavily in the 70s, dealing with children, something called parallel problem solving. Parallel problem solving is where a number of small groups face the same problem. So, for instance, I want to move something, you know, 5 feet up. Just that simple. I want to move something 5 feet up. I want to use the least amount of energy possible. You can take advantage, you know, you have to specify very carefully what your initial state is. But there's a number of ways of doing that. You could use a motor and a chain. You could use a counterweight. You could use, you could use an unbalanced gyroscope, and then it would tilt this down this side and go up this side. You know, crazy things, crazy, crazy solutions that aren't necessarily useful, but it is a way of solving a problem that hasn't been considered before. So, but it's not, what's the point of moving something 5 feet up in the air? Well, somebody might need to do that for something completely unrelated. And having access to, all right, we had 20 teams, and here's the 20 ways they solved it. 5 teams solved it with a gear and chain. Out of them, they had this specific problem, you know, how to keep the thing from, you know, falling over when the weight is at the top of the chain, of the pole. Some of them solved it this way, some of them solved it this way. Well, somebody else comes along and says, well, I need to do that, but I need to do it in the least amount of space possible. Well, now you have 5 examples of how people did it and how much space they took. So you have something solid to analyze to say, you know, here, 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 this is the best choice. The analogy in software would be one of the things, you know, you don't reinvent the wheel. You don't go back and write code that somebody else has written. If you have something you need to do, you search for a library or an API or something applicable to the problem that you're facing. You search for somebody who's had to face this problem before and hope that they contributed a tool. If they didn't contribute a tool, you look for their notes even. Just the research they did, the information they brought together, even though it's all available to you, the fact that that specifically is what they brought together is useful. If you're looking into web agents, semantic web agents, which are little pieces of code that scour the net for specific information and stick it together in an XML style so that it's all accessible, bringing the net together on a specific topic. If that specific topic is already, if this has been done already, if somebody said, I'm going to write a research paper about so-and-so and created their bibliography but never finished the paper, that's still useful. That's still, you know what your starting point is. One little thing on concepts versus skills. A lot of people get caught up, for instance, when someone says, I want to hack, because they're talking about learning a skill. And a skill takes a lot of time, a lot of energy to teach, a lot of time, a lot of energy to learn. And it's not just time and energy. It's not like you can just throw it at that. It's also will. You have to want to teach. They have to want to learn. There has to be some kind of motivation to do that. Which means either the community has to hold that up as a noble thing to do so that you get some kind of recognition, which unfortunately is often people's motivation, is some form of recognition, at least within this community. Some people would argue with that and say that they are pure and are only interested in advancing things, and that is the ideal. That is what sort of you want to see, but it's not. I think, why a lot of shit gets done. It's why a lot of shit gets talked about. But when it comes down to dedicating 3 months to building a robot arm, people have built robot arms. There's a lot of information about robot arms. By doing it yourself, you're learning a lot of important skills. But there's a lot of things you could have been doing, but you were motivated to do that because it's cool, because it's interesting, and because it also gives you an opportunity to learn about motor control and a number of interesting topics. The ability of a group to learn. So you're working on a project, and you have some people in the group who know how to, let's say you're building a robot arm, right? You have people in the group who want to learn how to build it. You will have people in the group who know how to build it. The challenge, and this is more applicable to managers than anything else, this little part here. The rest of you guys already sort of know about this innately. The challenge that you're presented is also an opportunity to educate each of the members of the group in the processes necessary to accomplish the goal. Am I speaking too fast for anybody? Somebody mentioned that was a problem? All right. So since you're having to apply these tool chains, to steal another little term from programming, to a problem. So I know it takes this step to get from here to here. Action and then state. You reach a new state. And then there's another action from there, and you reach another state. Each of those actions isn't something like this, it's something like a command line, and it's very specific to the problem you're facing at the time. So telling someone how to, for instance, build a new kernel, you can tell them, make xconfig, click this box, save it, click the nice little other box, and then make dep, make modules installed, all that crap. Or you can teach them about make and show them how to see the different options. You can teach them all these little things, but they don't require all that to build a kernel. They require all that if they want to, at some point in the future, be faced with a problem of, oh, I need to build a kernel, and be able to solve that on their own. It's like, give a man a fish, he eats for a day, teach a man to fish, he eats for a lifetime. But people want to learn the skill and don't have the time, don't have the energy. And to solve a problem, you often only need to know the existence of the solution, the existence of the potential for the solution. In organizations, like say a corporation, each of the departments has access to keys, metaphorically, to information about how different parts of the process work, processes that people use every day. The IT department, one small section of the IT department, maybe one guy in the IT department, will know exactly how the email system works. So when symptoms show up as problems of the email system, for instance, maybe you're, to steal an example from something someone just had, your XM filters are rejecting this one server because it is not speaking proper SMTP. Well, the symptom will be, oh, I can't get your email. That's the call that the help desk will get. Well, the help desk isn't directly related to the person who knows the system. So maybe the help desk will say, oh, your email isn't getting through. Well, let's go through all these troubleshooting steps. They'll spend all this time, and it could take weeks before finally someone says, oh, we're having this problem, and the guy says, oh, I saw that in my error logs. I know what that is. No problem. And to face this problem, some people have meetings that are supposed to bring together, for instance, the entire IT department, where you have the sysadmin, you have the security guy, and everyone talks about the issues they've been having, and if somebody in the larger group has a solution for it, then they'll offer it up. But it still doesn't end up, there's minute problems that people face, things that aren't more annoyances that you get so used to solving in a very complex way. For instance, someone who doesn't know at all about the command prompt and is using Linux, trying to set up a network card. They're going to apply the tools that they understand, which is pointing and clicking within the interface. If they were aware of the tools available to them, then they would be able to do it much more efficiently. And they're capable of educating themselves, but they don't, largely because you can't just go on the internet and say, I want to learn how to write an instant messaging client. You have to understand enough of the problem so that you know what specifically to search for, what kind of API you need, what kind of software you need to start writing, how the software should be structured. Some of the worst code out there is from people who went at a problem without fully understanding the problem. So they applied the tools that they'd viewed in other problems that they'd faced, other projects they'd worked on, and applied to something that was totally irrelevant. They came up with something that worked, which is a testament to their skill in a way, but if they'd been able to talk to someone who either was a little bit closer to the problem or had faced it before in some form or another, then they would have been aware of more efficient tools. One thing that becomes possible within the open source community is code review. Very basic idea. People can look at what you've done and say, oh, I know how to do this more efficiently. See what you do in 12 lines? I can do it in 2. So there's always that opportunity, but it doesn't happen as a process. And that's the opportunity that's presented by enthusiast groups, like the CCC, like 2600. And as I mentioned, I found out upon getting here, the CCC has a significant amount of organization versus 2600 as far as how things are set up, where sort of funds come from, things like that, so that it's a very different feel. So it might not quite apply to you guys as much, but I think it's important. One thing that happens inside of corporations, for instance, just to use an analogy that everyone should be able to relate to, since I'm sure everyone, a number of people in here have worked at a help desk or something similar, is you end up with a structure. The entire company is based around toward a very specific set of problems. And for instance, your research will be separated from the people solving problems that users are facing. Even though it's really the same thing, You know, the research people are taking different input than your people solving problems. And it's not even viewed as an issue. It's not viewed as a concept to move that information over, to share that information, to share the problems that are being faced directly and not being complained about necessarily, but just, oh yeah, we know the answer to that, just do it this way, you know, sorry about that, that's a feature, not a bug. We should have explained it a little bit better in the documentation. That's what they'll do, they'll expand the documentation rather than saying, oh, well, people don't understand this innately, maybe we should change it. So some of the ways to view the education of these processes. So cryptography is heavily based in mathematics, and a lot of the people doing the conceptual work and the software for crypto don't necessarily have that excellent a basis in mathematics. There's a woman in St. Louis named Alonka. At the last 3 Freaknik conferences, where they release a complex crypto puzzle, she has been the first one to break it. She's been doing crypto puzzles for a long time. She has numbers. There's the Alonka code, but she has no formal training in mathematics. She has an innate ability rather than a trained ability. At this point, it's a trained ability because she's had access to the specific information that's available only to cryptographers because she's gone out and seeked out that information. But originally, the way she discovered she had this ability was because a friend of hers presented her this problem and said, I understand how to do this tiny bit, and these are the tools I applied to get to this point. What do you think? And she said, oh, well, you know, I know of these things from my software experience, and I know of these tools and concepts. I've seen a computer do this, I've seen a computer do that. I know what a hash is, I know these different concepts, so I think you can do it this way. And she ended up being right and incredibly successful at it. But you end up with a lot of this, where, for instance, non-engineers might have some of the best ability, design-wise, to come up with new ideas, but they don't have the opportunity because they'd have to self-educate. So getting new memes, as it were, introduced to the community at large, to the public, is, I believe, in timing with the goals of the hacker community. The more people you can get thinking about different topics, and the more people you can get thinking about the tools toward those topics, the more new ideas will come out. Dialogue versus argument. A lot of people, when they hear 2 people going at a problem from different angles, will think, oh, that's an argument, it's bad. It's not necessarily. It could be dialogue. Dialogue is where each of the people is saying, all right, this is how I know this is. And I say no, not as a certainty, but no because once you think something, you often know it, unless you make a specific note not to know it, but just to think it, you know? The example is we all used to think the world was flat. Now we know the world is round, but we knew the world was flat then. I think it's from a movie. So people have difficulty shifting these paradigms, and even if they're presented with a different solution, they'll think, oh, that's cool, but since they may have faced the problem in the past and solved it with the tools they knew, they won't use the way that they know somebody else solved it, even though it's more efficient. You know, you don't have the time when you hear about something to immediately do an analysis in your head of the efficacy of that thing, of that process. You just sort of put it in as a tool set, and then maybe if the first tool fails, then you'll try the other one. And there have been times when doing that ended up making a discovery, you know. Maybe it increased the efficiency of some other part because it produced slightly less heat. So you were able to make this other part significantly more efficient. Or you were able to reduce the size of the fan by 30%, you know, things like that. So transparency of processes is important. A lot of people I talked to about, I wanted to, in a game, integrate a way that people could watch how hackers were doing what they were doing. There's a number of very cool tricks that people do with GDB, the GNU debugger, and Perl. From inside GDB, you can run, and then the executable mark, the little bracket, and then a command, and then close, and you can basically very quickly pull a command into GDB and run it however you wish. Run an executable however you wish, pipe whatever you want into the executable. Whatever you're working on, it makes it very flexible. So if you're working on something where you need argv2 to be 10,000 A's, you can run little executable mark, Perl-E, open quote, and this is a trick I stole from someone else, print, open quote, A, close quote, times, a little X, 1,000, and then you would close the single quote and then close the executable quote, and it'll put 1,000 A's on the command line. And if you needed it argv2, you do 1 space and then your executable little section, and it'll take all that. It's standard command replacement. But when people try to solve these problems on their own, they end up with these crazy solutions for putting 10,000 A's on the command line, such as putting 10,000 A's in an environment variable, and then specifying that environment variable on the command line as one of the arguments, or populating a buffer and then using exec.le to specify that buffer as one of the arguments to the program, doing their own special execution. So I approached some people with the idea of showing via screen what people were doing on the command line when they were hacking, actually breaking in, exploiting code, hardening systems. And they were totally against it. Nobody wanted to do it because it's embarrassing against your peers, because the solutions you've come up with for these very difficult problems are often sort of ghetto-rigged, as it were. Maybe not the most efficient, but they work, goddammit, so more power to you. And there were a number of reasons why people didn't like this idea of showing everything they were doing on the command line. It made them feel uncomfortable. It made them feel like the information would be accessible. There were all kinds of arguments. And I think there's a lot of different ways you could sort of view that. But just to give you an idea of sort of where we are right now, even though that would be an ideal situation to be able to see how things are actually done, it's not acceptable at this point. It's just a cultural thing. Maybe that's different in the US, but I think if you ask most people who really have, skills, if they want to be watched as they do everything, they're probably going to not be too happy about it. So I've explained the difference between a concept, which is sort of access to knowledge of a skill, and a skill, which is understanding how to do this thing. Understanding the usage of GDB is a skill. Understanding that with GDB you can print out the memory of a program is a concept. If you're faced with a problem where you need access to the memory at an arbitrary point in the running of a program, then you only need to know the concept of, oh, GDB does that, to be able to RTFM and get access to what you need. But if you actually want to immediately be able to use GDB towards your goal, then you have to have it as a skill. You have to fully understand its usage. So if I know that, say I'm in the 60s, and I need to create a section of core memory, I need a way of addressing bits, and I have these little toroids that I know that if I put a charge through them, the right amount of charge, it will swap that bit, and I'll be able to read it back later. But being able to cross the wires in such, I don't know how many of you have seen core memory. It's very interesting how they solved this problem. They crossed wires, so there's wires here, wires here, wires here, wires here, wires here, that are crossing at different angles. And say you want to address this bit here, well then you have to specify this wire and this wire. And where they cross is that point in memory. There's also wires coming up from here, so I don't fully understand it myself, but it's interesting how they solved it. It's more of a woven material. So somebody had to say, oh, this is the way to solve that. But maybe there's some kind of crazy weave that has 8 different sets of wires that go in, and only one point where 8 unique wires cross. But to know that, you would have to know about weaving. You'd have to know about looms and things like that. And there's an incredible amount of information about weaving that nobody really had access to, because there are people who specialized in it, and unless you're specialized in it, then you're not really going to learn about it. And the people who are specialized in it have created lingo, have created, just as any other field, have created specific things that describe ideas within that field that there isn't a text file for, Once again, it's like, how do you explain a buffer overflow if somebody doesn't understand memory management? It's sort of tricky. But people expect you to do it. And, you can't just be an asshole and say, fuck you, you noob, I don't know, RTFM, because that's a huge amount of information. There's no memory management meta file for complete understanding. You have to have schooling in it, you have to have experience in it. And to gain that experience, you have to be able to participate in a project. But when you have nothing to contribute to the project, but the little bit of brain juice, it's difficult. It's difficult. So how do you bring new people into a group if they honestly want to learn? Somebody new comes, they are interested in the topics, say they're an archaeologist, and have an interest in computers, an ability to learn in computers. Where do you start them off? Is it worthwhile to start them off? Since you have limited time and limited resources, do you test them somehow to see their natural ability and see whether or not it's worthwhile? Would it be better to test large amounts of the population to try to find geniuses? One thing that happens in the States is children who don't do well in the public school system often go into the military. The military has a battery of tests. One of them is called the ASVAB. Based on the ASVAB, they're able to tell if you have natural abilities within a number of different areas. And based on these tests, rather than anything that happened in public school, they just don't care. They only use their tests to determine where they're going to place you. They will put people who in school did very, very badly in highly technical areas where they've had no experience whatsoever and train them. The reason being, sometimes these people are incredibly capable. And this is the benefit that militaries, for instance, have when dealing with crypto, for instance. There's a section of these tests that's dedicated to mathematics. If you do well on that section of the test, they'll train you in mathematics. Perhaps not directly in the crypto area, but maybe they'll put you in an engineering field that requires you to spend a few months doing math. And they'll monitor your progress and say, all right, I think this guy's going to be pretty good at it. Let's use him for something that we would normally need a PhD for because he has a natural ability. And then what ends up happening is you gain these abilities through their training, but then when you leave, you have to take some crappy job. This has gotten better recently. This is more a problem that many people complained about in the 80s. The companies that would take advantage of this situation and take people from the military who were in technical fields into their private corporation, who were black companies, as it were. So you worked on classified projects, you couldn't share what you knew, and you often couldn't even say where you worked. So let's say you get laid off, It's a little bit difficult to get a job if you can't say, oh, I did such and such, but they still have the ability, they still have the skills, even though nobody would have given them that opportunity normally. They might be an electrical engineer who would never have been an electrical engineer otherwise. So the more people you meet and the more people you can sort of give new ideas, the more potential there is for someone to become interested and dedicate some time. But there's got to be motivation. One of the simplest motivation is resources. Say I want to learn electrical engineering. I want to learn the basic concepts. I want to learn microcontroller programming. It's an easy example. That means that somebody has to provide all of that, all those resources. But it's not just that, it's also providing the skills. You know, if I don't know how to do it, that means somebody has to be there who understands how to do it and who can show me how to do it. But that takes up their time, which they could be dedicating to solving the problem that we're all faced with, whatever the project is. So where do you draw the line between time spent educating others, which is worthwhile because then they're capable of applying those skills towards solving the problem also, because there's always parts of a problem. There's never just one grand problem that, you know, everyone's sort of stuck working against and there's no way of spreading it out. You can always sort of break up a problem. So if you can teach people, then they can do small parts and everyone can sort of contribute. So that's the goal. You want people to be able to contribute as freely as possible to as many small parts as possible, rather than everyone working at the same thing, going in different directions, no organization. So how do you do that? How do you balance the time? Well, you know that you have to provide at least enough information so that they can educate themselves. You can't just say, you know, go and read this book. It's probably got too much lingo in it. It's probably got too many things that just don't make sense if you've never had experience doing whatever. So you have to spend some time teaching the basics. So maybe you start with, you know, how electricity flows. Well, just talking about how electricity works within a circuit can take a significant amount of time, and there's a lot of technical details which are absolutely necessary, a lot of formulas which are necessary to understand. You know, if you don't know Ohm's law, how are you going to do electronics or electrical engineering? But you have to learn it, and you can't. It's not easy to just learn it from a book if you don't have mathematical experience. You have most people who honestly do this work and who have to know these formulas and are not horribly mathematical have learned it because they've had to use it time after time after time after time after time. It's innate to them now. So you can't expect people to do what you weren't able to do yourself. You can't expect people to just soak things out of the air. Just looking at someone pick a lock is not enough necessarily to learn how to pick locks. You have to feel the pins being pushed up out of the way. You have to not only see it but also feel it. You know, it's very tactile skill. And the only way to do that is usually to have someone sitting there saying, all right, good, watch this. You see how I'm pushing it in and pulling it up and pulling it out? All right, now do that. All right, that looks good. You know, you need that kind of feedback. And that can only be provided interactively, which is, of course, horribly inefficient because then, you know, ideally there would be software solutions for these sort of things, you know, some way of magically spreading information and spreading skills, but there aren't right now. There are attempts to do that sort of thing. There are a number of educational projects being put on by universities. And interestingly, the code on these projects is often very closed to the public. It's not very rarely open source projects because they're funded by corporations who are interested in better ways of doing their research. These aren't problems that people face only when they're trying to build a robot. It's problems people face when they're trying to revise their HR system. It's problems people face, problems teachers face every day. You have students who don't want to learn. And so they've created systems for teaching those students, even though they don't want to learn. And that's why those tools aren't immediately applicable, because the idea is that hackers do want to learn. You know, they do want access to the information, and they want it in as efficient a manner as possible, because that's just a good thing. So how do you do that? How do you get information directly to people as quickly as possible? Well, synopsizing. The skill of taking a complex subject, cutting it into little bits, little tidbits of information that are keys to further information, so that you know, oh, well, I would apply this here. You know, you don't need to know what this is fully, you just need to know where it applies. But people don't really do that. They get deep into their subcategory and specialize. You know, over-specialization is a problem. And it's becoming more of a problem as more and more tools are developed which make it possible to specialize. For instance, cryptography, now you've got symmetric key cryptography, you've got public key cryptography. I don't know enough about it to properly comment, but it's a lot of different fields. So you don't have an overarching crypto guy anymore. It doesn't really exist. You have someone who's very good at one thing, usually. You don't have an overarching Uber programmer, you know, meta programmer. You have programmers who specialize in areas and write code, and that's largely because when you're writing a project, you're not writing code that's meant for anything, even though that is, you know, you want the most flexible code possible, which implies writing it for any potential usage, but it's still towards something, you know. You can't just write code for solving problems. You write code for sending this type of message over this media, you know, this sort of thing. So specialization is more and more sponsored, more and more, you know, it's very easy to fall into, while communication between specializations becomes more difficult, especially as the lingo separates. I don't know if lingo is a word that's heavily used. I don't know if that translates very well to, but it means words that are specific to a field. So for instance, RTFM could be said to be hacker lingo, because who knows read the fucking manual outside of people who have seen it and who have had, you know, said, what does that mean? And somebody said, oh, that means blah, blah, blah. Or saw it and searched for RTFM dictionary and came up with a dictionary that had RTFM read the fucking manual in it. So there you can see sort of how people try to gain access to information they're interested in, but aren't always that successful, because there is all of the associated information that is sort of assumed. If you're reading this paper, you know about these things, and I'm going to assume that because I can. You know, if you're interested in such and such a topic, then you already must know this, this, and this. What's the point of writing a paper about the basics, about the overarching concepts, when my entire audience is very specialized? That's sort of the idea. I mean, it's not rewarding directly to try to teach people about the basics of anything. I wanted to present on very basic ways of performing exploitation of code. And it wasn't generally considered a good idea because the people who would understand it would think it was too simple. The people who wouldn't understand it would think it was too hard. So where can you get in there? Where's the point where you can get new people interested, get new people educated, and yet make it interesting to the people who've been there a while? Well, the answer is you can't. You sort of have to specify, oh, well, this talk is for, people who don't have experience in this area, or this talk is extremely technical. And people try to, sort of convey that in the synopsis of the talk, but not always successfully. One of the tools that is used in academia pretty heavily is Socratic dialogue. How many people know what Socratic dialogue is? Socratic dialogue is where the teacher asks questions of the students and forces them to consider the problem and come up with their own solution based on what they've learned in the past. What this means is that not only is there the potential for new solutions, though that's not really the point, the student is required to apply the knowledge that they've gained in the past toward a problem. It's from Socrates, Socratic dialogue. But it's interesting because not many people know about it, yet if you really want to share information quickly, if you want to share technique quickly, if you want to expand on technique, then one of the most efficient ways is to stand there with a peer and ask questions and see how they respond. And this is a very new concept in the way people are communicating technically nowadays. We just started doing this in trying to do this sort of thing. There's another word for it, flow of thought, where you say whatever you think is related to the last thing you said, and you keep doing this and keep doing this and keep doing this and keep doing this. The idea being you're I was supposed to have a little board here somewhere, but I'll try to explain it. If you view all of the potential skills within an area in a network, this skill depends on knowledge of these skills depend on knowledge of these skills, blah, 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 blah. You get this crazy little web. So maybe my knowledge is over specifically in here, very close to the edge. So I know generally this area, but there's all the rest of these skills that I don't know about. So the idea would be to jump from skill to skill as quickly as possible, mentioning, oh, I do this, I do this, I do this, I do this. How would you do this, 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 and this? Well, I do this, I do this, I do this, I do this. How would you do this, 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 and this? I do this, I do this, I do this. The idea is efficiency. But people aren't used to that. People aren't used to structured language. People resist structured language. There have been attempts. Basic English. One interesting thing is 1984 was actually written because of someone disenfranchised with current attempts at the time to write structured languages, universal languages that everybody could sort of use to communicate complex information with no language boundary whatsoever, like Esperanto. The argument and the reason he wrote the book against them is because meaning is lost. Shades, nuances that have been slowly developed over years and could potentially be completely gone if it was moved to a smaller language. Some of these languages, just to clarify, you're talking about between 1,500 and a few thousand words. There's not much opportunity there. Most of them have some kind of scheme for creating compound words, which is where you put the meanings of two words together, or suffixes, prefixes, Latin roots, that sort of thing. But even with those roots, there's only so many potential combinations. The idea with natural language being that if there is a need for a new concept, a word will be created. But how do you decide which words can be safely removed, which nuances can be safely removed? How do you decide which words to compress down into one and which to stay expanded? And so that's part of what Newspeak, what he was talking about with Newspeak in 1984. He was trying to lay out the problems that these type of languages would create. the kinds of issues that would be faced by a society that was trying to use these. So that's sort of interesting. A lot of people don't know about that. There's a word in German, Schadenfreude. Schadenfreude has no translation in English. To explain Schadenfreude in English requires a large amount of explanation. You have to go into, there's no quick phrase even to say it. Oh, he's happy at another person's, bad luck. Oh, okay. Well, I need to wrap up here. Sorry about that. That's pretty much it. One other thing I want to mention is parliamentary procedure. Does anybody know what parliamentary procedure is? Parliamentary procedure is a process by which a group can make decisions. It's very interesting if ever you're faced with a group that needs to make a complex decision concerning an issue. It's used by the United Nations. It's used by the UK's Parliament. And it is a set of rules, a set of very specific rules that a group can follow to face an issue. So if you're interested, Socratic Dialogue, Parliamentary Procedure, on www.rootdruid.com, I'll be putting up a paper along with all of the links to this form of information. It's interesting, and I thank you for your time. Thanks.